You didn't have to unsign it for me. I assigned it. I have this score you have like a bunch in my backpack. I got all of the raspberry ones and I just ran with them. That's my favorite flavor. Ooh, that was kind of great. What about the math knowledge question? I got a B. 12? It was 11 point something, right? Yeah, 11.6. But it rounded to 12? You have set up proportions? Okay. Today we're looking at lesson 65. We're looking at radicals in trig equations, and then we're going to look at graphs of log functions. All right, so let's look at an example. We've dealt with trig equations already this year, but we have not dealt with them that have radicals in them. But we have dealt with radical equations. What do we want to do with a radical equation? Take the radical out. Okay, so how would we get that radical out of the equation? Yes, you would have to get your radical alone. So what do you want to move? Okay, I would have negative square root of 1 minus sine squared x equals negative sine x. Okay, get rid of the negatives. Then what? Square both sides. So what happens to the left side? It goes away. The radical is gone, and you're left with what was left in the radical, 1 minus sine squared x. What about the right side? It is now sine squared x. Now what? Now you want to move this one over. So it would be 1 equals 2 sine squared x. Now what? Divide by 2. So I have 1/2 equals sine squared x. How am I going to solve for x? What do? We need sine x. What would you do? How do we get rid of that squared? The square root. What is the square root of 1/2? And anytime you take the square root, what do you have to remember to put? A plus or minus. Okay. So x equals what? Okay, 45. And 135. And 225. And 315. Okay, but here's the only thing. Whenever you have radicals, you have to plug your answers back in.
and we have to make sure they work. But here's the thing. You only have to check 2 of them because these are both, the 45 and the 135 are both for sign positive. And then the 225 and the 315 are if it's negative. So we plug in one of the 45 and 135 and then one of the 225 and 315. So you don't have to check all 4 of them. So let's do the 45 degrees. What is sine of 45 degrees? Okay, square root of 2 over 2 minus 1 minus. What is sine of 45? Squared, because it was sine squared. Okay, 1/2 equals 0.
Teachers, pardon the interruption. There is a silver Hyundai SUV. You have left your lights on in the student parking lot. That is a silver Hyundai SUV.
What is the square root of, well, what is 1 minus 1/2? What is the square root of 1/2? Does that work? Okay, so 45 degrees works and 135 degrees works. Now, when we go back and check it, what is the sine of 225? It's not just the square root of 2 over 2. It's the negative square root of 2 over 2. But over here, whenever you square it, that negative goes away, right? So that one doesn't change. So all we have is that. Does that equal 0? No. So those 2 aren't the answer. Only these 2. You'll see how that works? Now, sometimes all 4 of them will work. Sometimes none of them will work. If all 4 of them work, then you put all 4 of them. But if none of them work, what would you put for your answer? No solutions. Okay? You could also put, kind of looks like a butterfly, means null set. Or you could put that, if you want. All right, so let's look at another one. This one is a little bit easier. That's okay. We don't have a radical dealing with our trig, it's just dealing with a number. So it makes it a little bit easier. What does that little thing mean? Our answers are going to be in radians. So we're going to find them in degrees and then change them into radians. Okay, so how are we going to solve 4x to get them in degrees, first off? No, you do not want to distribute because that's going to make it messy. What would you do to solve that? You set them both equal to 0? So what would tan x equal? What is tan x equal to? Square root of 3. Okay. And then what would our other one be? Sine of x equals -1. All right. What angles give us a square root of 3 for tangent? Let's check. Is the tangent of 30 equal to square root of 3? So it's not 30 degrees, it's 60. What other angle gives us a square root of 3? 240. It's in the third quadrant. Okay. Let's check on sine. What would give us a -1 for sine? Remember, this is one of the quadrantal angles, either 0, 90, 180, or 270. It would be 270. Okay, before we change them into radians, we want to check and make sure that all those answers work. Can we do sine of 60? What does it equal? Okay, plus 1 is a number. What did tangent of 60 equal? Minus square root of 3, 0 times a number gives you 0. 240 also works, right? Now let's check 270. Over on the right side, sine of 270 is -1, plus 1 is 0. What is the tangent of 270? Oh. Can we do undefined times 0? So does x actually equal 270 for this one? So the only two that we need to convert into radians are those two. Do you remember how to convert into radians? Multiply by pi over 180. So x would equal pi over 3 and 4 pi over 3. And those are your answers. So if you forget to check your answers, your answer won't necessarily match up with the answer key. You'll have too many answers sometimes. So if you have too many answers, go back and check and see which ones wouldn't work. All right, so moving on to graphs of log functions. We want to sketch the graph of log base 3.5 of x. And we're going to have to use our calculator. Do we know how to plug in log base 3.5 of x on our calculator? What can we plug in? Log base what on the calculator? Log base 10 is the only one you can plug in on your calculator. So can we plug in log base 3.5? But what can we do with our log? Put it in another form? Okay, how could we rewrite it? .5 to the y equals x. Okay. So should I plug in numbers for my X or for my Y? All right. What numbers do you want to plug in? Good numbers. What do you get if you plug in 1? Yes, 3.5. What do you get if you plug in 0? And what do you get if you plug in 3.5 to the negative 1? Okay. Now what? So we're going to go over to 3.5 and go up 1. Huh? Yeah. So you're going to go over to 1. And then you're going to go over 0.3 almost and go down to negative 1. Now what? Okay. What else? No. Gotta have another end. Where does it keep going?
Keep going down.
Does it ever cross the y-axis? So it gets really, 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 really close, but it never actually crosses. Do y'all see how those work? That's all you do with those. You just change them into exponential and then use a t-chart. Okay? So what is your homework? And when is it due? No, when is it due? Monday. All right.